Effective data management is about more than just storage, it's about visibility and control. In this overview, we'll explore how the data catalog in Dataverses manages your data lifecycle. Now, let's take a look at the interface. On the main dashboard, you'll notice our environment is organized into distinct catalogs. By clicking into the Dataverses_catalog, this brings us to the overview page, the central command center for managing our data. It provides the vital signs of our catalog in one view. We can see lifecycle metadata, infrastructure details, security and access parameters. Now, let's switch gears and look at the sample_datasets catalog. It is organized into multiple namespaces to keep different data projects separated and easy to find. Namespaces are essential for scaling. They act like logical folders that group related tables together. As your data grows, this structure prevents your catalog from becoming cluttered. But what if you're starting a new project? I'll show you just how simple it is to expand. By clicking Create Namespace, we can instantly define a new home for our incoming data assets. For this walkthrough, I've created a namespace named Demo. Now that our namespace is created, let's go inside to see how it's structured. Since this is a brand new space, you'll notice the tables, views, and volumes are currently empty. A namespace is just a container. Defining tables here, we make the data searchable, secure, and ready for analytics across the entire organization. I'll do this by adding files directly to this namespace, bringing our source data into this managed environment. First, we'll select our compute cluster to handle ingestion. Then, we'll choose our catalog in the demo namespace to ensure this table is registered in the correct location. Now, we'll choose the file for upload. I'll select the olist_orders_dataset to begin importing our records directly into the catalog. We'll rename the table to orders for a cleaner. The system defaults to CSV since that's our upload format, but it also supports auto-detect, JSON, Parquet, and Excel. Before creating the table, let's quickly preview the data. Dataverses shows the file size and total columns. We can see this file has 8 columns. And we'll use the 100-row sample to verify our structure before finalizing the import. Let's take a quick look with preview data to verify. Everything looks good, so we'll finalize with Create Table. The file has uploaded successfully. Our table, sample_datasets, demo, orders, is now live in the catalog with 99,441 rows ready for analysis. Back in our demo namespace, we can see our managed orders table alongside the original olist_orders_dataset.csv volume, giving us full visibility into both the structured data and the source file. Let's explore the orders table details. We have a full overview, the defined schema, and preview data to understand our structure. For deeper technical health, we can dive into insights and optimization, while the history and table properties tabs allow us to track every change and manage our core metadata. The Overview tab provides a complete snapshot of our asset, showing the owner, last updated, file size, and exact storage locations. We can also verify our 8 columns, the 99,441 rows, and any associated partitions. Moving to the Schema tab, we can see our 8 columns in detail, including the column names, data types, and nullability. It also manages keys, default values, and descriptions for complete data documentation. It's important to fill out the description field. This provides the context our Dataverses agent needs to accurately analyze the data and generate insights for you automatically. Dataverses offers 2 ways to add column descriptions. You can enter them manually, or let the AI generate precise definitions for you based on the data context. Let's try the manual. We first choose our cluster to power the update. Now, I'll add a description for the order_status column. Saving it now, and the description for order_status is successfully added. Now, let's try the generative AI way. With our cluster selected, we'll click Generate. The system analyzes the data patterns and automatically populates descriptions for the remaining columns, saving us a ton of manual work. Generated successfully. Now we can review the suggestion. If something isn't quite right, you can deny or retry the generation, or, as I'll do here, make a quick manual adjustment before hitting save to finalize everything. And it's saved. The order_purchase_timestamp is updated successfully. Continue it. Our table will be fully documented and optimized for both the team and the AI agent. Now, let's see the actual records. In the Preview Data tab, we'll choose our cluster and click Fetch Preview. This instantly pulls a 100-row sample, allowing us to verify the data quality and structure at a glance. To get a deeper look under the hood, we'll open the Insights tab. After selecting our cluster and clicking Fetch Insights, the system retrieves the live technical metadata for this table. Once the data loads, we get a comprehensive snapshot summary. We can see we have 99.4K records added with 0 deletions, and our last write was on February 7th. In the Storage and Performance section, we can verify that our data is stored across 2 Parquet files. Most importantly, the system confirms our compaction status is optimized and healthy, with a balanced distribution across our partitions. This ensures that no matter how large the data gets, our queries stay lightning fast. Now, let's continue to explore the Optimization tab. This is where we ensure the table stays lean and performant over time. If you want to adjust how the system handles background tasks, simply click the Edit button under the Optimization configuration. Optimization jobs are designed to run at appropriate times to minimize any impact on your table operations. Here, you have direct access to key maintenance actions, compact files, merge small, fragmented files into larger ones to maximize read speeds. Remove orphans. Automatically delete unreferenced data files to save storage. Expire snapshots. Clean up old versions to keep your table history efficient. Let's switch to the History tab. This provides an immutable audit trail of how our data has evolved. It captures every operation, like appends, updates or deletes, alongside the exact time, record count, and data size. By also logging the specific engine used, Dataverses ensures total transparency and governance for every change in our pipeline. In the Table Properties tab, we see the deep technical metadata. This confirms the table owner is Spark and verifies our optimized storage settings, using Parquet as the default format with snappy compression for high-performance data handling. If you no longer need this table, you can easily delete it. Dataverses gives you full control to decommission assets and manage your workspace resources efficiently. By selecting Purge Data Files, you permanently remove the underlying storage to save costs. For added security, you must type the table name to confirm, preventing accidental deletion of your production data. This security extends across the platform. Whether you are deleting namespaces or volumes, Dataverses enforces the same added security, requiring you to type the exact name of the source to confirm, ensuring your entire data structure remains protected. Finding your data is just as easy. Use the Smart Search to instantly locate specific items like tables or volumes directly from the root. It bypasses the hierarchy, letting you jump straight to your assets no matter where they are stored. Now that we've mastered catalog basics, our next video dives deeper into the Dataverses_catalog. We'll explore our 3-tier architecture, the bronze, silver, and gold layers. I'll show you how to transform raw bronze data into refined gold using Dataverses notebooks for advanced engineering. Plus, we'll cover why permissioning is critical to securing this pipeline. There is much more to explore in the catalog. Stay tuned.